Okay, good morning. Welcome to
FamilyMath1011a 1010.
Yeah, I'm not sure if it's 1010 or 1011, but it's one of those two. So today we're gonna look at an interesting project in coordinates. So you just learned about three-dimensional coordinates yesterday in your pre-calculus book. What did you learn?
Well, it's similar to two-dimensional coordinates, except you add the z direction.
Okay.
And there are also different types of three-dimensional coordinates. There's like cylindrical coordinates and spherical coordinates as well.
Yeah. So we're going to do something with just rectangular coordinates today with cubes. And it's going to build off of something that we've done before. One project inspired by Federico Ardaglia found Pascal's triangle in cubes.
Okay.
Do you remember how that worked?
No, actually, I do not.
Do you?
I think it was something about passing a n-dimensional cube through a plane.
Yeah.
Oh yeah, I'm looking at the number of vertexes.
Like kind of,
Or the number of corners that the resulting shape
and
had.
like you kind of stand it on its edge and pass it through the plane. I think the plane is one dimension less than the cube.
Okay. Yeah, that's a great memory. So if we start out with a zero-dimensional cube, what can we say?
Well, when you pass it through the plane, only intersects at the point where it's on the plane, and it has one vertex.
That's right. So we could write that as a 1. What about a one-dimensional cube?
Well, when it starts, it has 1. And if you go along, it ends at 1 as well.
So we could write 1, 1 like that. And what does it mean to call this a one-dimensional cube?
Well, in one dimensions, you only can go back and forth like this along the line.
Okay.
So a cube is sort of, it's any shape with sort of the same size edges and right angles, but you can't have right angles in one dimension, so it's just a line.
Okay. All right. Well, why don't you tell me about this one? Now, this is what we could call, for purposes of this project, a two-dimensional cube.
So you stand it on an edge, or on a point like this, and then pass it through, and you get 1, 2, 1.
Okay. So that would be 1, 2, 1. And what about a three-dimensional cube?
So you pass it through like this again, and then you get 1, 3 is bottom 3, and then 3 is top 3, and finally 1 again.
Okay. 1, 3, 3, 1. And now we have a hypercube.
Well,
It's a little trickier to see what's going on here.
so you go 1, and then you go up. I guess maybe this would be considered to be on the same level. 1, 4. And then you would consider these edges. So you'd have 1, 2, 3 on this inner cube. They would correspond to edges on the outer cube. 1. So let's see. Where'd they be? It'd sort of move up
What are we hoping we find?
6.
Yeah.
So because we want 1, 4, 6, 4, 1.
So there'd be 1 on each of these vertexes. They would align with these, and we'd get 6. You can sort of see it passing through these.
Do you see the 6?
I think so. I have maybe a little bit different way of thinking about a 6.
Yeah. Oh, go ahead. Explain it.
So I would keep the 1 and the 4. So this is the 1, and then 1, 2, 3, 4.
Okay.
And then since we do the same thing for the top, 1 and 1, 2, 3, 4, the 6 could just be the remaining 6 in this middle cube.
Interesting. Okay, so maybe that's an interesting point, so that we could say 1, 4, then 1, 4, and then somehow there's 6 left in the middle.
Because if we do these two the same way, then we have 6 in the middle, and then it should be a remaining 6 somehow.
Okay, so since we started looking at coordinates yesterday, let's see if we can understand the coordinates in this way, the 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, and then maybe it'll make a little more sense why there's 6.
Okay.